So we have yet another LLM at our disposal. In this case, it's from Mistral, and the name of the model is Magistral, and the whole point of this model is that this is a reasoning model. I believe it's their first as well. So that's pretty cool. I would like to give this a spin. And what I figured I might share is maybe one of the easier ways to give any LLM model a spin, really. Even if it has a slightly different API, assuming that you can connect with it with Python, there's a fun little pattern that you can follow to just try to get an understanding of what a new model might do. So let's talk setup. I'm inside of a Marimo notebook over here, and I'm setting up Mistral. I'm loading in an environment variable. That API key is going into the client, and this client knows how to talk to Mistral. Also notice that I've configured the Magistral small model over here, which is the reasoning model, and that means that this client can actually talk to this new model. And what I could do is I could go straight through with the Python API. Their docs have this one example over here where we ask the LLM about the best French cheese. And what I'm going to do is I'm going to copy this API and combine it with the chat UI that Marimo offers. And that looks a little bit like this. The way the chat UI works is you have to give it a function that can accept some messages as well as a config. These messages are a list of message objects, and they have a role property as well as a content property. So I'm able to unpack all of that and really just reuse the API straight from the docs. On top of that, I can also use Marimo's state API to also store all of those messages on the side, such that I can inspect them more thoroughly if I wanted to. But this is enough to kickstart a chat UI. And because this is an instruction model, I figured what could I maybe do to really lure out this instruction behavior? So what I've asked it to do is just calculate a large sum. This is what the chat widget looks like. This is what I filled in as a query. And you can see I'm just really adding two numbers together. And lo and behold, the model really does go thoroughly deeply into instruct mode. At some point, you can see that it just writes the two numbers down vertically so it can try to reason about it. And I gotta say, you gotta do a lot of scrolling if you're interested to really understand what it's doing under the hood. And I am talking pages and pages and pages here. It is really doing quote-unquote text-based reasoning. One thing that's particularly interesting if you read all of this is you can actually see that it cross-validates itself multiple times. So it came to a conclusion, it already knows that this is the correct sum. It then tries to reason why it may or may not be correct, and once again, it starts to align all these numbers vertically. Now, eventually, when you scroll down all the way at the bottom, you're going to see that it indeed found this sum that we're looking for. This is probably the most expensive way to calculate a sum, by the way. And I'm not an expert on the model, but I think it's reasoning so much, partially because I've chosen to go with a smaller model. I can imagine a larger model would maybe be a bit better in control of when to stop reasoning. But what I can do is copy that number, and I can indeed compare the actual sum with the number that it produced, and I can confirm that it is, in the end, correct. So this is what the new Mistral models do. They really do this reasoning thing. But as far as Marimo and rapid prototyping goes, there's this one extra thing that I want to highlight, and for that I'm going to turn this reasoning off. So instead of the reasoning model, I've gone ahead and used the small model over here, and that allows me to demonstrate this one extra thing that you could do. So let's just talk in very short turns. So I can do something like, hi, give me a joke. What do you call fake spaghetti? An impasta. Fair. Now do a joke about some other food. What do you call a potato at a computer? A chip. Okay, so corny jokes. But the thing that's interesting here is that I have a multi-column setup, so I could make this column a little bit smaller. Let's also zoom out a bit. So I've got two columns over here, and on the column on the left, you can really see the widget. But on the column to the right, you can actually see that the information that is being shown inside of this widget is also available to me on the outside. And the reason for that is I've declared a state variable. At the bottom here, I have mo.state declared. That is going to be some state that I can get and set. I have two functions for that. And this set state is actually being used inside of the function that the chat UI uses. So after I get my response back from Mistral, then I quickly set the state anew by taking the response and adding that to all the messages so far. And because the state over here has been set, I can also get it. And that's what I'm doing over here. And I'm using a little bit of mo.html to be able to print nicely and have a nice little UI, but you can definitely see all the user assistant turns happening here, which also means that as you're maybe playing around with the chat UI, you also have access to everything that's under the hood. You can still use that list. You can still maybe log that. You can send it wherever you like. And this is a, I think, pretty pragmatic setup to both do rapid prototyping, but also to explore new models whenever they come out. Because it's just a Python function you got to wrap around, this is a really nice way to just see what new model providers have made. And given that there's a new model every week, twice a week, something like that, this can be a nice way to poke around.